Hey guys, Stealth Cutter Juju here, and welcome back to another Java tutorial. In this tutorial, I decided to use a different screenshot position so that you guys can see what I have going on over here, what code I have, and what's actually going on in the console, so I don't have to move around the screen for you guys to see, and you can see right as it happens. So I think this works better. If not, go ahead and tell me if you like it yourself better down below, and maybe I'll change it. I don't know. So let's go ahead and get started. In this tutorial, I'm going to be teaching you guys about threads. And now, so to do this, what we're going to need to do is, for this demonstration, is go ahead and create a new class. And so to do that, you go ahead, write, yeah, you guys should know the procedure by now. I'm going to go ahead and call it my thread. And, okay. Now, first off, I'm going to explain what a thread is. And what a thread is, it's a way of thinking on, it's a way of making the computer doing multiple processes at the same time. See, if we go, I'm going to go ahead and open a previous project, and in this, what happens is it runs the first line of code in this thread, but it does everything line by line. It goes ahead and runs this line of code, then it runs this line, then this line, and then it runs this 3 times, and then it runs each one of these, but line by line by line. And what often happens is that, depending on the program, such as games or for chat programs, things like that, you can't just have one thread, because you need to listen to everybody at once, not just wait for every single person's input. So you have to wait for everybody, and then you have to maybe that's what I'll do, is I'll create a little chat program to show you guys what I'm talking about in a later tutorial. But for now, if that didn't make sense, I'll try and go over it back over it near the end of the tutorial. So to do this, what we're going to need to do is, like we can do in extending our main shape, we can actually extend this as thread. But what happens if we do that is that sometimes we get a lot of unnecessary stuff, and sometimes it can throw weird errors at you. So what I like to do and prefer to do is implement and just go ahead and implement runnable. And now what it's saying is, oh, Juju, hey, you went ahead and used this, you made it runnable, but you didn't promise to keep your end of the bargain, because what happens is, when you go ahead and use things like runnable and thread even, you'll say things like, oh, you need to create this method. If you want to use me, you have to do this. And so it's like a trade. So let's go ahead and add on implemented methods. And alright, it created that method for us, so we didn't have to go ahead and type it. But I'm going to go ahead and create the constructor too, just to show you guys how this is actually working. And so when the constructor is built, I'm just going to go ahead and print out to the console. And I'm also going to pass in that, so thread ID was created. Now ID is not exactly useful. Oh, how did I get I also reset my line numbers. I actually reset all my settings. That way I wouldn't get that weird annoying glitch that I had in the other tutorial. And yeah, okay, so I'm gonna have to make id int id, and this dot id equals id. Alright, and now when this goes, I want it to go ahead and print out thread id started running. Whoops. Okay. And yeah. Alright, that looks pretty good. And what I'm going to do here is how we make each one run individually is we go ahead and create our thread. And so we just go ahead and type, there we go, that's how you spell it. Thread, th, or t1 equals new thread. And I'm going to go ahead and new my thread, and I have to pass in an ID, and this one is 1. Okay, has started running. I'm going to edit this so that we can see. I'm just going to make it go from perhaps alright, and okay, and it's just going to add it to a sum, I guess. That seems reasonable. And sum plus equals I, and let's go ahead and print out that it's finished. Now, what this should do, if it's not, yeah, I know, it's not actually used, but shh, just shh. So, what if this wasn't threaded? What would happen is, well, the constructor would run, and so the constructor should obviously all happen at the same time, but, I'll wait, and then near the end, if I remember, I'll go over it again. Hopefully I'll remember. And let's go ahead and change the ID for each one of these so they match. And I'm going to say t1.start. Okay. And, now, what's going to end up happening if it wasn't threaded, what would happen is this constructor would run, this constructor would run, this constructor would run, and then this constructor would run, which would make sense. And then the first one would go around and then go through, and then it would finish, and then the second one would start and go through its method, and then end. And then the third one would go through, and etc. But if it's all threaded, then each one should actually go about the work simultaneously, meaning that they're all being processed at the same time. So let's go ahead and try this out. So I'm going to go ahead and run. And as we see, thread 1, 2, 3, 4 was created in that order because this is not actually in the constructor. Thread 1 has started running. 2 and 3 have already started running, but 1 hasn't finished, so that would So because they're all running at the same time, we know that it's in fact not, what's the word I'm looking for? Oh, that it is in fact threaded. They're not all in doing it line by line. Also, if you notice, thread 2 finished first before thread 1. And I guess that's because thread 2 was a little bit faster, despite the fact that thread 2 started running after. And then thread 3, and then it wasn't until thread 3 finished that thread 4 actually started. And if we run it again, okay, and you can see that we actually have different results this time. 1 and 2 started running, and 1 and 2 finished. Then 4 and 3 started running, and 4 and 3 finished. And it's just dependent on the speed. If I had a more complicated thing going on here, it would actually take longer. But I hope this helps. If you don't completely understand, I'm just going to go ahead and go over this one more time. So we created 4 threads and used our class, which is a runnable type. And then we started all 4. Then we went ahead and in our class we implemented the runnable. And to solve the error that it got angry at us for, we went ahead and inherited our run method. We went ahead and created a constructor with the global variable ID just to keep track of which thread is running. And then we went ahead and went out and printed this all out. Just some random calculation to slow it down a bit. And then we went ahead and said that thread has actually finished. So again, what's happening is each thread is running at the same time and running this code all at the same time, or close to it, depending on how fast it gets through, which seems each thread solves it very easily. If it wasn't threaded, it actually, it'd say thread 1 started running, thread 1 started running, thread 1 had finished, thread 2 started running, thread 2 finished. That's a lot to say. Anyways, I hope this helped. If you found this video useful, go ahead and give it a like. If you want to see more of my videos, go ahead and hit that subscribe button. This was Juju, and I hope to see you in the next tutorial.